Hi grade 9s, this video is moving on to some slightly more fun quadratic equations. So the previous video did the basics of quadratics with you, and it's a new type of equation, so it'll take a little bit of getting used to. So there's going to be nothing new in terms of steps in this video, but our examples are just going to be a little bit more interesting. So let's start. First example says solve for x, 3x squared minus 27 equals 0. So let's just remember what our basic steps were. In every single equation that you ever do, you should first ask yourself, am I working with a linear equation? What are linear equations again? Linear equations have just plain x in them. Or am I working with a quadratic equation, which has x squared? Now this is actually a really important question because linear and quadratic equations have completely different ways of going about solving them. So the first thing I look here is I see an x squared, and so I immediately think it's a quadratic. Now, this is the learning part of maths. Part of maths is learning, and then part of maths is just doing loads and loads and loads of examples. Now, the part of maths that is learning is the part that says to you in your head now, right, it's a quadratic equation, what are the steps I follow? And the steps, the first step for a quadratic equation is get one side equal to 0. Now, you'll notice in this particular equation, wonderful. One side is already equal to 0, so that's great. What's our next step? Our next step is you're going to factorize. Don't forget that the whole goal in a quadratic equation is to factorize to get two factors multiplied together to give you 0. So I need to factorize. Also, don't forget that the first thing you do when you factorize is you look for a highest common factor. So in this particular example, I do see a highest common factor because 3 is common in 3 and 27. And there's nothing else that's common, so I get x squared minus 9 equals 0. Now that's wonderful, you've taken out a highest common factor, but 3 can't equal 0, so this isn't helpful yet at all, because this is entirely pointless. So 3 cannot equal 0. So therefore the 3 is almost, besides the point. It's really kind of pointless, is I suppose the word I would use. It's pointless. So actually, often what I do, instead of factorizing out a highest common factor of 3, what I'll often do is just divide by 3. Because in an equation, you are allowed to divide by a number, not a letter, a number, as long as you divide everything by that number. So you can divide that by 3, that by 3, and that by 3, and then I'd get x squared minus 9. Is 0. Now a lot of people don't like doing it that way because it gets a bit confusing. So I'm going to continue these questions where I'm not going to divide by, but I could. So what I've noticed here is that's wonderful. I now have 3 multiplied by x squared minus 9 equals 0, but 3 can't be 0. So what do I know? I know that x squared minus 9 has to be equal to 0. So you can keep this 3 along for the ride, or you can drop it. It actually doesn't matter. It's entirely pointless in the question now. So what do we do once we've checked for a highest common factor? We then check for a dots, or we check for a trinomial. Now in this case, x squared minus 9 we know is a dots, so I change this to x plus 3 and x minus 3. So this is why factorizing is so important. Now again, this 3 here, you don't have to have it there. This 3 can be there or it cannot be there. It really doesn't matter. And now this is wonderful because once you've got two factors, each factor could be 0. Because when you have two factors multiplied together to give you 0, one of them has to be 0. So the 3 cannot be 0, so it's pointless. I'm going to ignore it because 3 times anything, 3 times 0 would be 0. So all I actually care about is the fact that x plus 3 would need to be 0, or x minus 3 would need to be 0. So either x has to equal to minus 3, or x has to equal 3. So the thing that made this question more difficult or challenging or complex in the previous video is that in the previous video we just had a highest common factor or a dots. This was a combination of both. And in fact, that highest common factor which we took out of 3 didn't affect the question at all, so it was entirely pointless. Okay, let's move on to some more examples. The more examples you do, the better we get. So let's look at B. 2x squared equals 50. Now don't forget to write down these notes. These equations are so important, and so good notes are going to help you a lot in the future. So is this a linear or a quadratic equation? Oh gosh, it's got an x squared, so it's a quadratic equation. So now that I've decided that, what's my first step? I need to get one side equal to 0. Now I don't have that in this question. I have 2x squared equals 50. So what I need to do now is I need to subtract 50 on both sides, so that 50 disappears on the right hand side, and I get 2x squared minus 50 equals 0. What do I next do? I need to factorize, because the whole goal of a quadratic equation is to factorize to get two factors equal to 0. What's the first thing you do when you factorize? The highest common factor. 2x squared and 50 has a highest common factor of 2, and x squared minus 25. Now again, I have 2 here. Now this 2 cannot equal 0, so this is entirely pointless. You can ignore it. You can bring it along for the ride, or you can divide by 2 on both sides and it can disappear. So I'm going to ignore that 2, but I'm going to continue to factorize. So either it's a dots now, or it's a trinomial. Now in this case, I have a dots. So I'm going to keep the 2 along for fun, but I could just stop writing it there by dividing by 2 on both sides. So I'm going to ignore the 2, and I'm going to say, well, 2 can't equal 0. 2 cannot equal to 0, therefore ignore it. So actually, all that matters, let me change color here for my last step, is that each factor could equal 0. In fact, one of them has to. So either x plus 5 has to be equal to 0, or x minus 5 has to be equal to 0. So x either needs to equal to negative 5, or x needs to equal to positive 5. Great, onwards. Next question. 4x squared minus 49 equals 0. First question I ask myself, is this linear or is this quadratic? I see an x squared, and so I think it's quadratic because of that. Second step, get one side equal to 0. And fortunately in this question we're quite lucky, one side already is equal to 0, and so I can soldier on. Next thing I need to do is I need to factorize. And the first thing I do when I factorize is I look for a highest common factor. So is there something common between 4 and 49? Well, 49 isn't even, so 2 doesn't go into it, and 4 doesn't go into it, so there is no highest common factor. So what's the next thing I check for? Is I check for a dots. Now this is a dots because it's a difference, and these are both perfect squares. So one's a plus, one's a minus. So what multiplies by itself to give me 4? This is 2 times 2, and x times x will give me x squared, and 49 is 7 times 7. Last step, each factor could equal 0. So now I know that either 2x plus 7 has to equal 0, or 2x minus 7 has to equal 0. Now the reason I chose this particular example is that actually now solving these two little linear equations is actually a little bit more complicated than we have been doing. So in the first one I'm going to subtract 7 on both sides, so I get negative 7, and then I'm going to divide by 2. So my answer is actually a fraction. It's not a problem. Or, in the other side, I'm going to add 7 to both sides, and then I'm going to divide by 2. So I get 7 over 2. So you'll notice I'm using exactly the same steps that I have been using. The only difference here is the factorizings have been a little bit more difficult. Okay, on to some more interesting ones. Next question. First step, is this a linear equation? Or is this a quadratic equation? Now these steps that I'm going through, this is almost what you have to talk yourself through in an exam. When you hit any exam question, you should be talking to yourself. If you're not talking to yourself, you're not doing maths properly. So you need to be saying in your head, oh gosh, is this linear or quadratic? Oh gosh, I see an x squared, it's quadratic. So my next step is to get one side equal to 0. Doesn't really matter. So I have a look at this and I see x squared minus 2x. So that's great. Let me get everything to that side. So I'm going to subtract 15 on both sides. And now I need to factorize. And the first thing that I do when I factorize is I look for a highest common factor. And when I look at this, I get x squared, I get 2x and 15. That doesn't have a highest common factor. I then ask myself, is it a dots? Well, it's 3 terms, so it can't be a dots. Is it a trinomial? Well, it's 3 terms. Does it fit the pattern? There's an x squared, there's an x, and then a number. This very much looks like the pattern of a trinomial. So what multiplied by x by itself gives you x squared? That'll be x times x. Okay, now we have to remind ourselves, we haven't done trinomial factorizing in a while, so let's remind ourselves what the steps are for that. The first step is to look at your constants and say to yourself, what can multiply to get 15? Well, our options are 3 times 5 or 15 times 1. Those are pretty much it. Next step is I look at my sign. If this is a minus, my signs need to be different. So you need one of these to be a plus and one of these to be a minus. Now, which option do we pick? We look at the middle term. I need the middle term to be minus 2. So which one of these can combine? It's definitely going to have to be 5 and 3. So I'm going to put 5 and 3 in. Who's the plus and who's the minus? Well, you want these two to add to give you minus 2. So it's minus 5 and plus 3. So minus 5 and plus 3. So this one is more interesting because I'm bringing the trinomial factorizing into the question, which is definitely the most difficult of the factorizings. And now we carry on as usual. Either x minus 5 has to equal 0 or x plus 3 equals 0. So that step is that last step of the fact that each factor needs to have a chance to be 0. So either add 5 to both sides, x must be 5, or subtract 3 from both sides, x is minus 3. What's great is that in an exam you can always check if you've done this question right, because you can just use your calculator and sub in 5 and check that you get 15, or sub in negative 3 and check that you get 15. Right, onwards and upwards. Next question. Quadratic or linear? This definitely looks quadratic because it has an x squared. So done. Second step, get one side equal to 0. In this example, one side is equal to 0. Wonderful. Third step, I need to factorize. When I factorize, I always follow the same steps. Highest common factor, there's not a highest common factor here. Dots, well, this is 3 terms, so it can't be a dots. Trinomial, well, I think so, because there's an x squared, an x, and a constant. So if this is a trinomial, let's practice our trinomial factorizing again. First of all, I do the obvious. Obviously, x times x will give me x squared. Next, I say, let's look at 24. My options for 24 would be 24 and 1, which are highly unlikely. 8 and 3, 6 and 4, 12 and 2. So this have quite a few sets. Next, I'm going to look at my signs. My signs have to be different signs because they have to multiply to give you a minus. So one has to be a minus and one has to be a plus. And lastly, I need these to add together to give me negative 5. So this is definitely out. Oh, this looks promising because 8 and 3 can give me 5 and I need negative 5. So I think I need negative 8 and plus 3. So just luckily I happen to put those second on my list and they happen to work out. And so lastly, each factor needs a chance to equal 0. So either x minus 8 needs to equal to 0 or x plus 3 has to equal 0. So either x must be equal to 8 or x must be equal to negative 3. Hopefully you're getting more and more confident with those trinomials because that's actually the only difficult part of these questions at the moment. Okay, on to F, which is a lovely question. First question you ask yourself, is this quadratic or linear? I think this is quadratic because I see an x squared. Second question, I need to get one side equal to 0. Sorry, second step. That isn't done here. So I absolutely need to get rid of that minus 42. So I add 42 to both sides. So it means I get add 42 on that side and 0 on that side. Next step, factorize. And every single time, the first thing we need to check for is a highest common factor, which in this case I think is 3. So I get x squared minus 9x, and I think plus 14, if I'm not mistaken. I better just check that in my head. 10 times 3 is 30, and 4 times 3 is 12. So add them together, I'd get 42. Now again, don't be worried about this highest common factor. 3 cannot equal 0. So there's no way it's going to play a role here, so we're going to completely ignore it. Now we need to ask ourselves, is there a dots? Well, no, that bracket is not a dots. It's a trinomial. It fits the pattern. So you can keep that 3 along for the ride, but it's going to be entirely pointless. Right, what's obvious? Obviously, x times x gives me x squared. Not too many options for 14. My options are 14 and 1, which is highly unlikely, and 7 and 2. And my signs have to be the same signs. So either I need plus plus or minus minus. Now I know which one I need because, let me choose a better color, because the middle term is a minus. So I know it's minus minus. And so lastly I need to decide if I need 9, or 14 and 1 won't work, it's going to be 7 and 2. So it's minus 7 minus 2 will give me minus 9. And so my last step is that each factor could have a chance to be equal to 0. So I'm going to ignore 3 because 3 can't be 0. So either x minus 7 must be 0 or x minus 2 must be 0. So I add 7 to both sides, add 2 to both sides. And there we go. Right, now moving on to the next ones. Why don't, some of these are quite interesting. So I'm going to try G, and then I think you should try H before watching me do the memo. Okay, first thing, is this a linear or quadratic equation? Oh my word, this is a very interesting, and this would be given to you as a problem-solving question, because this is not linear. This is not even quadratic. This is a power of 3. We've never done that before. Okay, now this is actually called a cubic equation. Now, technically you only get taught to solve cubic equations in grade 12, but let's just roll with it and see what happens. If it's anything other than linear, the steps are always the same. The steps are always get one side equal to 0, which is done here. And then the steps are factorize. So, let's factorize. Is there a highest common factor? And what do you know there is? X squared is common. And that leaves me with x, because x squared times x is x cubed, minus 3 must be 0. So guess what? You have two factors multiplied together to give you 0. So each factor could equal 0. So either x squared must be 0, or x minus 3 must be 0. Now x squared will only be 0 if x is 0, because when you square something, you can only square 0 to get 0. Or you can add 3 to both sides, so you get x is 3. So this is actually called a cubic equation. And notice, I would give this to you in a test only as kind of a problem-solving, really difficult question. And you kind of just have to roll with, you wouldn't have seen this before, so you kind of just got to roll with it and see how it goes and hope for the best. So, if I was you now, I would hit pause and try and do h by yourself, because you'll notice this is also a cubic in h. It's got an x cubed. Try and follow exactly the same steps and see how it goes. Then maybe watch the video and see if you got it right. Okay, so hopefully you've tried it. Cubic equation, how weird. One side is equal to 0, so that's good for us. And so I don't really know what I'm doing. This is problem solving, but I'm going to factorize. And when you factorize, you check for a highest common factor. And there's an x. And that leaves me with x squared minus x minus 12. Now this is very much a problem solving question. This would be classified as very difficult. Do you notice something about that bracket? That bracket is now also a trinomial. Now, also, this, we've only ever had a constant there. Now, x isn't a constant. Could x equal 0? Well, yes. So actually, I'm not going to ignore that x. That x is going to be really important. Now let me factorize my trinomial. The obvious would be x times x. Then let's look at my factors of 12. 12 could be 3 times 4, 6 times 2, 12 times 1. And my signs need to be different signs because they're multiplying together to give me a negative. So one's a plus and one's a minus. But they have to somehow add, let me pick this color. They have to somehow add together to give me minus 1. And so immediately I think this set is a good idea. And I think it's minus 4 plus 3 will give me minus 1. Now this is where it's a bit interesting here. There are now 3 factors. So each factor needs to have a chance to equal 0. And x could equal 0. It's no longer a constant like 3, and 3 can't be 0. So guess what? This equation is actually going to have 3 answers, which is pretty cool. So either x must be 0, or x plus 3 must be 0, or x minus 4. So either x could be 0, or minus 3, or 4. Now again, chances of you ever seeing a question like this in an exam are quite small. I really am extending you here, just to expose you to some different things, but this would be classified as very much problem solving and something you haven't seen before. So that was quite mean. Okay, let's go on to another one. This one you could see in an exam. It's quite a nice question, but it would be classified as really complex. Now again, I would hit pause. You've done a lot of work with me and you've done a lot of work on equations. Hit pause, try it for yourself, even if you just tried in pencil, and then watch and see how it went. Okay, if this was me doing it, I would ask myself, is this linear or is this quadratic? And at this stage, I'm not actually sure because there's brackets everywhere. I don't know what's going on. I can't see if there's an x squared. And so what I would do is I would multiply out. I don't always multiply out because if you have 2 brackets multiplied together to give you 0, then there's no point in multiplying out. But I don't have 0 here. I just have a random bracket on either side. So let me multiply out. So I get 2x squared minus 2x equals 6x minus 6. Now I can go back to my first question. Is this linear or quadratic? Now I can see it's quadratic. So now I know what to do. I need to get one side equal to 0. So in this particular example, I'm going to leave my x squareds on this side. I'm going to minus 6x from both sides. So I get minus 6x. And I'm going to add 6 to both sides. Now I'm going to neaten that up and say 2x squared minus 8x plus 6 equals 0. And so what looked like a really complex equation actually has boiled down to a quadratic equation. Now I need to factorize, and the first thing I do when I factorize is I look for our highest common factor. So I'm going to take out a 2, so I've got x squared minus 4x plus 3. Now this is an example of where this 2 is pointless. 2 can't equal 0, so I'm going to ignore it. You can keep it around for the fun of it, but what do you notice? That bracket inside is a trinomial. So you'll notice we're seeing quite a lot of trinomials now. So obviously you need x times x. Now this is quite a nice trinomial because there's only one option to multiply to give you 3, and that's 3 and 1, so I can fill them in immediately. My signs have to be the same signs, and if I look at the middle term, it's negative, so I know they both have to be negative. And guess what? Minus 3 minus 1 does actually give me minus 4. And so my last step is that each factor could equal 0. Now 2 can't equal 0, so I'm going to completely ignore it. If it was a letter like the previous example, then I wouldn't ignore it, but it's not. So actually x could equal to 3, or x could equal to 1. Now, question I would be probably the most difficult equation question that you get in an exam or test. Definitely a little bit more complex because you didn't know what it was in the beginning. You have to multiply out, then see what it was, and then pick, kind of all the steps to solve in a quadratic equation. So definitely I is probably the most difficult question that you'd get, and it would be considered fairly complex. And those are basically all the examples that you really need. I've chosen just to throw one extra one in that looks like outrageously difficult, just to show you that you have all the tools you need in order to solve something that looks this ridiculous. Now personally, I probably wouldn't give you this ever in a test or exam, because it would be worth a lot of marks, and if you didn't know what to do, you'd lose too many marks. So this is just almost a little bit for fun. Now what do I notice here? Well, there's lots of terms. So the moment there's lots of terms, I like to divide into terms, just so I can see where I'm going. So I'm going to divide into terms. So that's one term. So there's two terms on the left hand side, and there's three terms on the right hand side. And so what do I do when there's multiple terms? I need to simplify each term. Now you'll notice why this would have to be so many marks, because there's so much going on here. So the first term on the left, x times x, x squared, minus 3x. Then I distribute in the minus 2, minus 2x, plus 6. So that was a good revision of a binomial times a binomial. Now, plus 2x, this is distribution, minus 4. Now that equals, now this first x squared, x plus 4 squared, you cannot distribute that square, absolutely not, because there's two terms. So I have to write out the fact that this is x plus 4 times x plus 4, and then minus 3x plus 10. There's nothing to do there. So if I add up my like terms on the left hand side, just to make it more neat, this is x squared, then that is minus 5x, plus 2x is now minus 3x, and 6 take away 4 is 2. On the other side, there's still some work to be done. So x times x is x squared plus 4x, and then plus 4x plus 16, and then minus 3x minus 10. Now again, I would probably neaten up the right hand side now, because it's a bit messy and I don't actually want to work with it that way. So this is x squared, this is plus 8x, 8x, take away 3x is 5x, and 16 take away 10 is 6. So immediately I see this, I'm like, gosh, this is quadratic, because now I'm finally down to something which I can recognize and think about how many marks we've already done. We've done binomials times binomials, we've done distributions, we've done like terms. So I would look at this and go, this is a quadratic. And so I need to get one side equal to 0. So I'm going to minus x squared on both sides. And the moment I do that, I realize it's not quadratic. It's actually linear. Because the moment I'm minus, I'm going to go x squared minus x squared, and they're going to cancel. So actually, I'll end up with minus 3x plus 2 equals 5x plus 6. This actually is a linear equation. It's not even quadratic. And this often does happen. Something appears to be quadratic and then it's not. So I'm going to subtract 5x from both sides. So I get minus 8x plus 2 equals 6. Remember, linear has a completely different plan. The plan here is x's to the left, numbers to the right, letters to the left, numbers to the right. So I'm going to minus 5x on both sides, and then I'm going to minus 2 from both sides, so I get 4, and finally I'm going to divide by negative 8. And so if I simplify that, I actually get negative a half. So let me just explain to you what I did there again. I minus 5x from this side, so I minus 5x from this side, so these two combine to that, and those two disappeared. And then here I'm minus 2 on both sides to get there. Now the beauty is you can always tell if you're right or wrong, because you just shove negative half into the original question and you can tell if you're right. Now this will be worth a lot of marks, so don't get thrown by a question like this. I've never seen this at test exam. This one was just for fun. Okay, now the beauty of checking is that I just checked my answer and it wouldn't work. And the problem of finding your error is that you can't see it forever, and so it's taken me forever now to figure out that I made a typo there, which is so So easy to do. Now don't worry, in a test exam, if you make a typo like I did, you lose 1 mark. So this was meant to be a plus 10. So if I just go and fix this now, this was meant to be a 26, if I add a 2 in there. Now, exactly the same thing continues, except this was a 26. So this was a 26 minus 2, which is 24. And 24 divided by negative 8 is negative 3. So my apologies. And I must say, if this was me in a test exam, I always check my solutions. It just helps me know if I'm right or wrong. And if I'm wrong, you mustn't get flustered. You go back, and if you can't find your mistake, you move on. It's possibly 1 mark that you lose. But if you can fix it. And so I have checked that solution, and finally I'm right. Okay, so those are quadratic equations. Quite a lot to take in, especially these ones. There's just a lot going on. And I'm afraid the only way that you get good at quadratic equations, especially ones, maybe not like J. J was a bit ridiculous. But especially those beginning ones, the only way you get really good at them is practice, practice, practice. And so we're going to do a lot of practicing of these. Don't forget to ask any questions, because this is a really, really important section. So ask for help whenever you need it. Okay, well done everyone.